Today we're learning to change the subject of the formula, and it's going to be involving squares and square roots. The thing that we're going to be doing is changing the subject of the formula to a letter that's shown in brackets. The previous video that I created was on linear equations, but this one here, squares and square roots. So let's get into this question here. Okay, so the first thing that we'll say is that we're going to do the exact same as what we did when we were solving equations, that we do the exact same thing to the left of the equal sign as we do to the right. So we just use the balancing method to work this out. Let's go through the questions. You can freeze the video, try the questions yourself, or replay them if you misunderstand something that's there. Here we go. Right, so I've got one equation, it's d squared equals e, and I have to change this to the subject will be d on its own. Okay, so if I see a square, the way I'm going to remove a square is going to be taking the square root of it, and that eliminates the square. So if I take the square root of the left side and take the square of the right side, square root of them, what I've got is these will eliminate each other, and that'll leave me with d is equal to the square root of e. Okay. Now, one of the strange things about the square root is that, say I had an example that r squared was equal to 9. Okay. So I've got a number in there that's squared and it equals 9. So 3 times 3 would work. Yep. So I would know that r would equal to the square root of 9, which would give me 3. But minus 3 would work, or negative 3 would work. So if I have this situation here, then what I'm really looking for is having a positive answer and also a negative answer that would come out there. Because my answer to this here would be positive or negative 3 would work for that equation that's there. So for each of these, I'm going to have a positive and a negative answer that comes out when I take a square root. Okay. Sometimes a question may say that the answer will be a positive value, then that would be a different case and you just state the positive value. Here we go. Let's get through some of these questions. So I've got p squared is equal to r over q. I'm going to change it to p. So quite simply, I'm going to take the square root of each side. When I take the square root of the right side, it must be everything, and my square root must cover everything that's there. The square and the square root cancelling out. P is equal to square root of r over q, and it's a positive and negative answer. Question 3. A is equal to 3r squared. Change the subject to say r. So for this one here, I'm going to reverse it round. So I'm going to say that instead of a equals 3r squared, I'm going to say 3r squared is equal to a. 3r squared is equal to a. Just to get r on the left-hand side of the equals, just to make it tidy. Don't want 3 there, so what I'll do is I'll divide by 3 on both sides, cancel them out because they'll be eliminated, and that'll leave me with a all over 3. It's not r squared I'm after, it's r on its own, so I'll take the square root of both sides. Okay, that would leave me with that being eliminated, leaves me with r is equal to a over 3, square root over everything, positive negative answer. Okay, question 4. A is equal to pi r squared. Okay, so this one here could be the area of a circle. Area equals pi times r squared. In here, I'm not sure if that's exactly what they mean, so I'm going to have a positive and negative answer. But if that was the area of a circle, then what we would be saying is the radius can't be negative, so we would eliminate the negative answer. So let's just change it round to r. So I'm going to change that to there and that to there. So pi r squared equals a. I'm going to get rid of the pi because I'm going to divide both sides by pi. That gets eliminated, leaves with r squared is equal to a over pi. I want the square away, so I'm going to take the square root of that side and also square root that side. Both same to one side as the other. That leaves me with r is equal to big square root a all over pi. And remember, it's going to be a plus or minus answer that I'll get from there. Okay, on to the next question. Right, so question 5. Okay, changing the subject to that's in brackets, okay? So getting a little bit more complicated. So I'm going to change this formula here to k. So I'm going to reverse it round first of all. So a fifth k squared h is equal to t. I'm going to get rid of that fifth. And to get rid of a fifth, or I'm dividing by 5 here, I'll times both sides by 5. Okay? So what that does is it eliminates the fifth and the 5. So k squared h is equal to, and I'll write it as 5t. Don't want h on the left-hand side, so I'll divide both sides by h. And what that'll leave me with is k squared is equal to 5t all over h. I don't want it squared. I want just k on its own, so I'll take the square root of both sides. If I take square root of both sides, that leaves with k is equal to 5t all upon h, square root, and you've guessed it, plus or minus. Okay. For question 6, you may have seen this one in physics. Okay, this equation. So let's change it round to v. Okay. I'm going to change the side round. That equals e. So don't want a half. So to get rid of the half, what I'll do is I'll multiply by 2. And I'll multiply the right-hand side by 2. So these will eliminate. That leaves with mr squared is equal to, sorry, mv squared, that's a v. mv squared is equal to 2e. Okay. I'm going to divide both sides by m to remove the m. So they'll eliminate. That leaves me with r squared is equal to 2e over m. And then I'll take the square root because I don't want it squared. So I want the v squared just to be a v. So square root that, square root that. So same as the left side as I do to the right. So v is going to be equal to 2e all over m, square root sign over everything, and remember a positive and a negative. Okay. Right, so that was something from physics and something from maths. So these would be 2 Pythagoras theorem statements, and I want this one to start with c is equal to. So this one's kind of relatively easy. I've got c squared on the left-hand side. So what I'll do is I'll take the square root of the left-hand side, and I must take the square root of the right-hand side. Okay, so because that's separated by a plus sign that's there, what I'll need to do is take the square root of everything that's there. Okay, so the square roots here eliminate, so that leaves me with c is equal to big square root over everything, a squared plus b squared. Okay, so I'm going to put a plus or minus in there, but if it was a Pythagoras statement, then it really would be a positive answer that we would be looking for. Okay. For this one here, I've got to do a bit of changing around because I want a as the subject of the formula. So I'm going to reverse it round first and get a to the left-hand side. So not done anything there really, just swung the equation round. I don't want b squared there, so to get rid of a plus b squared, I'll subtract a b squared from this side. So that will eliminate, won't it? And if I do that on the left-hand side, I must do it also on the right. I'll take b squared away from that side. So here we've got a squared is equal to c squared, subtract b squared. Okay. I don't want a squared there. I'm going to take the square root of this side, take the square root of this side here. Okay. These will be eliminated, the roots. Okay. And that's going to be a is equal to square root of c squared minus b squared. And what we've got is a plus and minus in there. Okay, and again, if this really was a Pythagoras statement, then that would be a positive answer that we would have coming out of there. Right, so getting a wee bit more complicated as we go forward. So you might recognise this this one here. So it's a volume equation. Okay, it's a volume of a sphere, and what we want to do is to change the subject of the formula to r. Okay. Right, so a bit of manipulation to do here. I'm going to swing the formula around and say that 4/3 pi r cubed, right, so this is a cubed thing that's here, and that's going to be equal to v, okay? What I'm then going to do is I'm going to take, let's see, I'm going to get rid of the 3 from the bottom. So what we'll do is we'll multiply both sides by 3, okay? So the 3's are then eliminated. That leaves me with 4 pi r cubed is equal to, and that's going to be 3v, okay? What I'll then do from there is I'll divide by 4 because I want to get rid of that 4. But what I could do, just to save a bit of time, I could divide this side here by 4 pi, okay? Because 4 pi divided by 4 pi will be eliminated here, and I'll divide this side by 4 pi also, okay? So what that leaves me on the left hand side is r cubed is equal to, and that's going to be 3v all over 4 pi. Okay. Now what I'm then going to do is I'm going to take the cubed root, as it's called. So the cubed root is a root sign with a small 3 there, and that's why the 3's are cancelling out. Okay, and I'm going to do the same to this side with a 3 there. Okay, so because the root and the power are going to cancel out, that'll be r is equal to the cubed root of 3v all over 4 pi. And we're not going to put a positive and a negative into that one there because it's a cubed root. Okay, because we don't have a negative answer and a positive answer when that's going to be an odd number. Let's look at this question here. Okay, so we're going to try and get C as the subject of the formula. I'm going to swing it round. I don't want a quarter, so I'll times both sides by 4. So just do a multiply by 4. These will cancel out. BC cubed is equal to 4a. I'm going to divide both sides by b to get the b eliminated from this side. And that leaves me with 4a over b on the right hand side. I'm going to take the cubed root, okay? So the cubed root, and that leaves me with c on its own because these eliminate. And that will give me a final answer of 4a over b cubed root of it. Okay, and when it's a cubed root, that's mainly what we'd be dealing with up at this level. If we were changing the subject of the formula, we wouldn't have a positive and negative for a cubed root. Okay. Right, so last page, just a couple of more questions, and then we'll move on to some of the work we'll be doing for today. So again, we're changing the subject of the formula. This one here is involving roots. Okay, so to start with a simple one, what we've got is root f is equal to g, or the square root of f is equal to g. So to get rid of a square root, so if you remember when we were trying to get rid of a square, we took the square root. The opposite of a square root is a square. So what I'm going to do is I'm going to square this side here. So if I square that, that eliminates the root sign there. So what I'd have to do from this side here, everything on this side, there only is one thing, but I'm going to square that side there as well. So that leaves me with f is equal to g squared. Okay, so there's my final answer. Nothing more than that. If I've got w is equal to root x, then I'm going to change the subject round, the formula round to have root x on the left, just make it a bit tidier. Okay, I'm then going to square both sides. I'll square that because that eliminates the root, and that leaves me with x on its own. And what I'll do is I'll square this side here, so that will give me w squared. Okay, so x equals w squared. So I'll move on to something just a bit more complex. So remember, we're just doing the opposite for each. So for this formula here, m equals 5 root n all over 4, I'm going to change the subject to n. Okay, I'm going to write it round the other way first of all. All over 4 is equal to m. Right, first thing I'm going to get away is going to be the 4. So I could multiply by 4 and divide by 5 and get rid of them right away. I'm just going to do it in steps. So I'll times it by 4 and I'll times this side by 4. That eliminates the 4's that are there. So 5 root n is equal to 4m. I don't want the 5 there, so I'll divide each side by 5. Okay, so that will eliminate here, leaving with root n is equal to 4m all over 5. What I'm then going to do is I'm going to square both sides, and just be careful with this one. I'm going to square all of this here, like that there. And what that will leave me with is n on this side, because the square and the root eliminate. And that leaves me with 4m all over 5 squared. Okay. What I also could do there is, if I remember the rules and laws of indices, what I can do is I can apply that square to the top and the bottom, and I have to square everything that's there. So another answer for n would be n is equal to square of 4m. I'm going to write it like this first, okay? 4m squared all over 5 squared. So I can split that if it's a fraction. That's the way I can work indices. And then what I'm going to do here is I'm going to square both of these things. So 4 squared, that's 4 times 4 is going to be 16. And that's m squared, because I have to square everything. 5 squared is 25. So there's an answer there. Some of these answers are good as well. So that's a good answer. That would be correct, and that would allow us to work out what n is equal to if we knew what m was. There's another way that we could write that formula. Right, for 14, so just a couple more to go here. Right, so I've got to get this formula in terms of x. So subject's going to change to say x is equal to. Right, so first thing I want to eliminate will be the b. I'll take that away from that side by adding a b on. So they'll eliminate, and I'll add b on to the right hand side. So I've got a root x is equal to c plus b. Okay. I don't want an a on this side here, so I'll have to divide by a, and that leaves me with root x is equal to c plus b all over a. I'm then going to square this side, and if I square that side, I must square this side as well. So that leaves with x is equal to, and on the top there, what I've got is c plus b all over a, and that's all in a bracket squared. Now remember what I'd said before with question 13, I could write it in a different way. I can't square each of these separately because they're separated by a plus sign. These were multiplied together, and what I would say is that that could be c plus b squared on the top, and that would be a squared on the bottom. And I can't simplify that any further. So there's my answer there. X is equal to either c plus b over a all squared, or on the top, c plus b squared, on the bottom, a squared. And here we go, last two questions. Right, so we're getting more complicated as we go forward. Right, so I've got a square root over everything here. That's x minus 5 is equal to a. Change the subject to x. So the first thing that I can get rid of here would be the square root that's over everything. Okay, so I'll have to do that first. So I'm going to square everything first on the left, and I'll square whatever's on the right as well. Okay, so what we've got here is, if I square that, the square and the root cancel out. So on the left, I've got x minus 5 is equal to, and that's going to be a squared that's there. What I'm then going to do is get rid of that 5 by adding 5 to that side. I'll eliminate that. I must add 5 onto the right hand side. So there, finally, x is going to be equal to, and we've got a squared plus 5. And that's that one completed. Final question. So quite a complicated looking one, I think. So I've got to change this formula to x on its own. Okay, so first thing I can see with this formula is I've got a 2 that's on the bottom. That's the easiest thing that I can remove. I can't remove anything else. I must move the 2 first of all. Right, so we're going to multiply everything on the left by 2, multiply whatever's on the right by 2. So the 2's are going to eliminate, leaving with the cubed root of x plus 7 on the left hand side, and that will be 2w on the right. Now the only thing I can get rid of here is the cubed root sign. I can't get rid of the 7 at this stage because it's trapped. It's like it's trapped there by the root sign. So if I cube everything, so instead of a cubed root, I'm going to cube everything to the power of 3. So I must cube everything on this side here as well. So what I've got here is I'm going to eliminate the cube and the cube root. So that leaves me with x plus 7 on this side here, and that equals 2w cubed. Okay, so 2w cubed. Last thing, I'm going to remove this 7 that's here by subtracting it. I'm going to subtract that from the right hand side also. So that leaves me with x is equal to 2w, and that's going to be cubed, minus 7. So there's an answer that I could have there. So remember, what we can do with indices is we can apply that cube to the 2 and also the w to simplify things out slightly. So that would be 2 cubed is 2 times 2 times 2. So that'd be 2 times 2 is 4 times 2 is 8. So that'd be an 8 that goes there. And w cubed. And I'm going to subtract 7 from that. So some reasonably complicated questions that we've got there, some relatively easy at the start, but hopefully you've got a flavour of how to deal with squares and square roots when we're changing the subject of the formula.